Hi everyone, thank you for joining. In this video we're going to solve another integer equations question. This is a question from the UK Mathematical Olympiad. So we have x, y and z which are positive integers, and we have this equality, and we want to find the value and all the values of x, y and z such that this equality is satisfied. If you'd like to pause the video here and try it yourself first, then we could go over it together. Right, okay, let's use the fact that the real numbers can be ordered, and of course we're assuming x, y, z to be real numbers, right? So let's write it as z is less than or equal to y is less than or equal to x. Since x, y and z are arbitrary, we can do this without loss of generality, right? So let's replace the y and the x here with z. That means we will have 1 plus 1 over z cube. Now it's not going to be equal, it will be greater than or equal to 2, right? Since z is less than y and less than x, right? Okay. Now, okay, so what are the possible values z can take? Okay, so let's look at some possible values. Well, if z is equal to 1, the left-hand side is clearly greater than 2. If z is equal to 2, well, we're going to have, what are we going to have? We're going to have a 3 over 2 cube, yes, which is clearly greater than, well, 27 over 8, which is clearly greater than 2. Similarly, if z is equal to 3, we will have 4 over 3 cube greater than 2, because this gives us 64, divided by 27, but since 27 times 2 is 54, so this is greater than 2. Now when you try 4, you will see that if z is 4, we will have 5 over 4 cube. Now that's equal to 125 divided by 64, right? And if you think about it, if you double 64, that's going to give us 128. So this will be less than 2. And that's the limit. So we want z to be 1, 2, or 3. Now all we have to do is test each case, right? If z is equal to 1, if we look at the original equation, what have we got there? We have 1 plus 1 over x times 1 plus 1 over y. Now, if z is 1, you have a 1 plus 1 over 1, which is simply 2, right? Is equal to 2. If z is 1, this is the equation. If we divide both sides by 2, we'll have 1 plus 1 over x. 1 plus 1 over y is equal to 1. Well, that's impossible if you think about it, since x and y are positive integers. That's impossible because we will have 1 plus something bigger than 1, that is 1 over x something bigger than 1. Similarly here, so you have, we will be multiplying two quantities, both are bigger than 1, and it will never equal 1. So for z is equal to 1, there is no solution. Now we look at the next possibility, when z is equal to 2. If z is equal to 2, we have 1 plus 1 over x into 1 plus 1 over y. Now, if z is 2, 1 plus 1 over z, so that would be 3 over 2 is equal to 2, isn't it? Okay, so that implies 1 plus 1 over x, 1 plus 1 over y is equal to 4 over 3. Yeah. Okay, now how do we solve this equality then? Now let's think about it. Again, the inequality we introduced was z was the smallest, so we said z is less than or equal to y is less than or equal to x. Now if we focus on this bit here and replace the first bracket with x with y, so we have 1 plus 1 over y squared greater than or equal to 4 over 3, since y is less than x, right? Okay. Now again, what are we going to do? We need to find the possible values of y. One way to do this, as we have previously done, we can test the values, or in fact we could simply solve the limiting case. Let's say we're looking at the case when the left-hand side is equal to right-hand side, then we will have 1 plus 1 over y is equal to, we're only considering the positive solution, so it's 2 over root 3, which is. So that implies 1 over y is equal to 2 over root 3 minus 1, which is equal to 2 minus root 3 over root 3. So we have y is equal to root 3 over 2 minus root 3. Let's rationalize the denominator. 2 plus root 3, that will give us 2 root 3 plus 3 over 1, yeah? Okay, so we have that. Okay, so what is 2 root 3? Well, it's 3 point something, and we're adding 3 to it, so it's 6 point something. In other words, we must have y to be less than 7. In other words, the maximum value we could give to y will be 6. This is number theory, so we don't want to go into square root of 3s or radicals and things like that. So you could simply test some values and you will see that you will get the same result, okay? So y must be less than 7. But what is the lower limit? So if you go back to 1 plus 1 over x, 1 plus 1 over y, we said that's equal to 4 over 3. This is the equation we're trying to solve. That we know that 1 plus 1 over x has to be greater than 1, right? Now, what is z in this case? Notice z is equal to 2, right? And y has to be, from this inequality, it has to be greater than or equal to z. So to begin with, y could be 2, for example. But if y is 2, what will we have here is that we will have 3 over 2, which is already bigger than 4 over 3. And since 1 plus 1 over x is greater than 1, so it's impossible for y to be 2, right? In other words, we must have 1 plus 1 over y to be less than 4 over 3, because we're multiplying with something that is greater than 1, which is 1 plus 1 over x. So if you test 3, you will see that you have 4 over 3. That would be, if y is equal to 3, we have that, right? But again, there's a problem here because we're multiplying that by something bigger than 1, right? So we can't have y to be 3 either. And if we test the next value, we will see then y can be 4, because 1 plus 1 over y will be less than 4 over 3, right? So in other words, we must also have y to be greater than 3. Strictly greater than 3. Since y belong to 4, 5, 6, this set, all we have to do now is we have to test. So we have 1 plus 1 over x times, when y is equal to 4, you're going to get 5 over 4 is equal to 4 over 3. Okay, so that implies we have 1 plus 1 over x is equal to 16 over 15. That means 1 over x is equal to 16 over 15 minus 1, right? Which is equal to 1 over 15. That implies x is equal to 15, right? So we found the first solution. X is 15, y is 4, and z is 2, right? Okay, so the next possible value of y is 5. So we have 1 plus 1 over x. 6 over 5 is equal to 4 over 3. Yeah, this is y is equal to 5 here. So that implies 1 plus 1 over x is equal to 20 over 18. So 1 over x is equal to 20 over 18 minus 1. Okay, so 1 over x is equal to 2 over 18, which is equal to 1 over 9. So x must equal to 9, right? So we have 9, 5, 2 as our other solution. The next and the last trial is when y is equal to 6. We have 1 plus 1 over x. Now if y is 6, we're going to have 7 over 6 is equal to 4 over 3. That implies 1 plus 1 over x is equal to 24 over 21. So 1 over x is equal to 24 over 21. Take away 1. That's equal to 3 over 21. So 1 over x is equal to 1 over 7 implies x is equal to 7. And the third solution is, we have 7, 6, and 2. That's the third solution, okay? So we found 3 sets of solutions here. Similarly, if you use the same method to work out for the last value, if z is equal to 3, and if you employ the same method, I'm going to leave this to you to prove it. If you cannot prove it, please write it in the comments that I'll write the proof explicitly. So the solutions you will get is 8, 3, 3 and 5, 4, 3. Right? That is for z is equal to 3. Of course, you need to work out the values of y before you solve that, just like in the method that we have used here, possible values of y, right? And then it should be quite easy to solve it. Now, one thing to notice here, so in total there will be 1, 2, 3, 4, 5 solutions that we worked out. But if you consider any of these solutions, for example, let's have a look at this solution that we worked out. 1 plus 1 over x, 1 plus 1 over y, 1 plus 1 over z. Z is 2, right? Is it equal to 2? This is what we want to test. So simply, we can write this as 8 over 7 into 7 over 6 into 3 over 2, right? Let's do some cancellations. 6 goes with 3, so 2 is there. 7 goes with 7. So what have we got here now? We have 8 divided by 4, which is equal to 2. It solves the problem. But what is more interesting is that any cyclic permutation of any of the solutions will also solve the problem, as you can see from the symmetry here. In other words, instead of having 7, 6, 2, let's do cyclic permutation, 6, 2, 7, right? So in other words, now we have 1 plus 1 over x, 1 plus 1 over y, 1 plus 1 over z. Okay, as you can see, that will give us 7 over 6, 3 over 2, and 8 over 7. Just like here, okay? So in other words, this will also be a solution. So this is also a solution. Yeah. So cyclic permutation of any solution is a solution itself, right? Okay. Well, I hope you enjoyed it. I hope you found it interesting and inspiring. Thank you very much for joining. I look forward to seeing you in my future videos. Thank you.